Hi there, and welcome to this lesson. And this lesson we're learning about basic algebra, okay? And we'll be doing introduction to algebra. Algebra. So, at this point, I'd remind you to set the video to play in 1080p HD. Very important, you do that, and you can do so via the settings icon on the bottom right, okay? And as the lesson progresses, if you have any issues at all, okay, if anything comes off as unclear, please feel free to get in touch, okay? We're always here, we're always happy to help, and you can do so via the course dashboard. Okay, so let's jump right into the lesson. So, introduction to algebra. What is algebra? Now, algebra is a part of mathematics that uses letters to represent certain quantities in equations and expressions. Okay, and for example, normally in arithmetic you have a straight expression with just numbers, okay? But then in algebra you have something like this. You can have a plus 1 equals 3, and this is simply asking what would you add to 1 that will give you 3, okay? And basically you can tell that that number is 2. A is 2. Okay, so there are different terms in algebra that we need to take note of. Again, the first of which is variables. Okay, now what are variables? Now, variables in algebra are quantities that are not fixed, quantities that vary, quantities that could be anything. For example, a, like we just saw, we've established that a is 2, but a on its own is basically, a could be anything, okay? A could be in another equation and a could be 5, okay? And basically a variable in algebra is whose value really hasn't been established, okay? It's not fixed, it could be anything pretty much. And these quantities are represented with alphabets, okay? So you have your x's, you have your y's, and etc. Now, terms. Now, an algebraic term is either a simple number, okay? For example, where we had a plus 1 equals 3, 1 is a term, 3 is a term, a is a term, okay? And it could be a simple number, a variable, okay? Like I just said, a is a term, or a product of a number and a variable, okay? So you can have 2x, i.e. 2 times x, that's a term, okay, that represent an individual unit in an algebraic expression, okay? So basically an algebraic term is either a simple number, a variable, or a product of a number and a variable that represent an individual unit in an algebraic expression. Now, the next thing we want to learn about are coefficients. Now, what are coefficients? Now, coefficients are numbers that multiply variables in algebraic terms. For example, I could have an algebraic term 5x, okay? And in this case, 5 is multiplying x. The coefficient of x in 5x is 5, okay? It's that simple. You can have an algebraic term 12y squared, okay? And basically you have 12 multiplying y squared, and then in that case the coefficient of y squared is 12, okay? So it's simply the number multiplying the algebraic multiplying the variable in the algebraic term. Now finally, expressions. Now when we bring it all together, when we bring terms and variables and constants, when we bring all of it together, basically we form expressions. For example, if I have like I had a plus 1 a plus a, let's say I had a plus 1 plus 2b minus y, okay? We bring different variables together, different terms, and we apply certain mathematical operations to them. We have expressions, okay? So and it's worth mentioning that whenever you equate an expression to a constant or anything, anytime you equate an expression, you pretty much have an equation, okay? But then we'll not get to equations just yet. We'll stop at expressions. Now, something important we need to learn about, and the concept of like terms. Now, like terms are terms that contain variables that are exactly alike. Okay, so for example, you could have x and 2x. Now the variable in the first term there is x, okay, because it's pretty much just all there is in that term. And then the second term, 2x, the variable there is x. So we have two variables that are exactly alike, x in the first term, x in the second term. So these are like terms. Let's try another one. What if we had 3y and 11y? Okay, so the variable in the first term 3y is y, and the variable in the second term 11y is y. Okay, these are like terms. Let's try another. What if we had x and 7y? Now the variable in the first term is x, and the variable in the second term is y. You probably guessed it. These are not like terms. Okay, these are not like terms because the variables are not exactly alike. The variable in the first term is x, the variable in the second term is y, i.e. they are not like terms. Now, what if we had 2x and x squared? This one's interesting because we have x's in both terms, and then with the variable in the first term is x, okay, and the variable in the second term is x squared. Okay, you need to be very careful about that. All right, we consider when you have it, when we have a square, or let's say x cube, we consider x cube as an individual distinct term compared to x, distinct variable compared to x, basically x in itself. So when we have 2x and x squared, the variable in the first term is x, and the variable in the second term is x squared. So these are not like terms. Okay, now what if we had 17x squared and 5x squared? Variable in the first term is x squared, variable in the second term is x squared, and you probably guessed it, these are like terms. Okay, so let's move on to something else, and let's talk about the basic operations we can perform on algebraic terms. So pretty much addition, subtraction, multiplication, and division of algebraic terms. Now, addition, x plus x. Okay, x plus x. When you think of adding algebraic terms, just think of the x's as ones. Okay, so you have 1 plus 1 is 2, x plus x is 2x. Okay, or just think of them as oranges. If you have one orange and you have another oranges, you have one orange and you have another orange, how many oranges do you have? So one orange, x, plus another orange, x, equals 2 oranges, 2x. Simple. Okay, so let's try another one. Y plus y is 2y. Similarly, okay, z plus z is 2z, m plus m is 2m. Okay, it's actually that simple, very straightforward. And then sometimes you could have 3x plus 2x. Okay, and you pretty much just add the numbers together. So you have 3 oranges plus 2 oranges gives you 5 oranges, i.e. you have 3x plus 2x gives you 5x. Simple. Let's try another. What if we had y plus 6y equals 7y? Okay, because if you have one apple and you have 6 apples, how many apples do you have altogether? You have 7 apples. Very simple, very straightforward. Now what about x plus y? Now x plus y cannot be done. Okay, you can't do anything about x plus y, because if I asked you, you have one orange and you have one apple, how many, what do you have? You pretty much have one orange and you have one apple. You can't have 2 apples or 2 oranges as a result. Maybe if you do some trade, but anyway, that's not relevant at the moment. But then if you have one orange, think of it as that. If you have one orange and you have one apple, and I ask you to add them together, you pretty much still have one orange and one apple. You can't add x and y together. Okay, and similarly, you can add x to a number. Okay, if you have x plus 7, you cannot add x. You can add a variable to a number. Now let's do subtraction. Subtraction is actually quite similar. If you have 2x minus x, you get x. Okay, so let's say you had 2 oranges. I took one away from you. How many oranges do you have left? One. Simple. Now, what if you had 2y minus y gives you y? Similarly, the same way, if you have 15x minus 8x, you end up with 7x. Okay, and then if you have minus 3y minus y, just like you'd work numbers, you have minus 3y minus y. If you had minus 3 minus 1, it will give you 4. So minus 3y minus y should give you minus 4y. Now, what if you had x minus y? Just in the same, just as you can't add x and y, you can't subtract them. So x minus y cannot be done. And similarly, when you have a number involved, like y minus 12, you can't subtract a constant or a number from a variable. It just cannot be done. Okay, so, and here's our favorite operation, because you can perform multiplication on pretty much anything. There's no multiplication that cannot be done. We can actually multiply numbers and variables. We can multiply variables and other variables. Okay, so let's jump right into it. So what is x times x? X times x is x squared. Okay, what is y times y? Y times y is y squared. What is x times 2? Okay, x times 2 is 2x. Okay, so let's say you have, or let's use 5 as an example. X times 5 will be 5x. All right, so let's say you have one orange and you multiply that one orange by 5. How many oranges do you have? You have 5 oranges. It's that simple. So we have x times 2 as 2x. Okay, and then what about y? We have 3 times y as 3y. We have x times y as xy. Here's an interesting one. What if we had 7x squared multiplying 2xy? Okay, now when you're multiplying something like this, because this is actually a complex system here, we have some pretty complex terms here. The first thing you want to do, you want to multiply the two numbers, the two constants. So you have 7 times 2 gives you 14. Okay, multiply the x's. You have x times x gives you x squared times x gives you x cubed, and finally you just bring in your y, so you end up with 14x cubed y. And when you're multiplying variables like this, it's very important, or we usually write them out in alphabetical order. Okay, for example, if I was multiplying a times I times m, I won't write it out as MIA. I would actually write it out as AIM. Aim. I actually didn't plan that, to be honest. But then yeah, let's move on. Finally, let's talk about division. Now, division. Division is quite similar to multiplication, but I think there's just one of them that can't be done. So if you have x squared divided by x, you end up with x. Okay, just like the way you multiplied x times x to get x squared. If you reverse that and you divide x squared by x, you end up with x. And similarly, y squared divided by y equals y. 2x divided by x equals 2. 7y divided by y equals 7. Okay, we're basically just reversing all of our multiplication. 3xy divided by y, the y's cancel out, and basically you have 3x. And x divided by y, you can't divide one variable by another. Okay, you just wouldn't get an answer. Okay, so that is pretty much all we need to know about the basic operations in algebraic terms. And as you continue to work with these, you would get very used to them. Okay, you get very familiar with working these. Okay, they're just very simple things you need to understand about doing operations on algebraic terms. Okay, so let's try some examples. Now, example 1. And example 1 says simplify 2x plus 2y minus 19x minus y. Okay, so Step 1. Now we have 25x plus 2y minus 19x minus y. Okay, so we know that we can't add 25x and 2y. We obviously can't do that. Okay, but then we can actually work the x's and work the y's, and I'm going to introduce you to something called collecting like terms. Okay, so what we do here is we actually bring the variables that we can work, okay, because you can't do 25x plus 2y. You won't be able to solve that, okay, but then there's minus 19x there, okay, and what you do is you bring the variables that you can solve together. This is called collecting like terms, okay, so you bring the variables that you can solve together, and basically you end up with something like this. Okay, so you bring minus 9, and anytime you're moving variables or terms, you move them with the sign in front of them. Okay, so we're moving minus 19x closer to 25x. Okay, so we move the whole minus 19x. What we end up with is we end up with 25x minus 19x, then the plus 2y minus y. Okay, and now we've simply rearranged this expression in a way where we have all the like terms together, and now we can perform operations on them. We perform the necessary operations on them, and basically when we go 25x minus 19x, we end up with 6x, and when we do 2y minus y, we end up with y, and that will give us our answer. Very simple, 6x plus y. Okay, let's do another example. Example 2. And example 2 says simplify 99x minus 12xy plus x plus 12xy squared. Okay, so step 1. We have 99x minus 12xy plus x plus 12xy squared. Now, obviously, the first thing we need to do here is we need to collect like terms. So what are the like terms here? We have 99x, and I think we have another x there. So we need to bring those together. Do you see any other like terms? Any other like terms? No, there aren't any other like terms, because 12xy and 12xy squared are not like terms. They're as different from each other as x and y. Okay, just the squared at the end of the y there makes a very, very, very big difference. You can't add 12xy and 12xy squared. They are completely different from each other. So we simply work the x's, and then we bring the x's together. We have 99x plus x minus 12xy plus 12xy squared, and what we end up in the end is 100x minus 12xy plus 12xy squared. And at this point, there's pretty much nothing else we can do, and that gives us our final answer. Okay, and that is how we collect like terms, okay, and perform basic operations on algebraic terms in expressions. Let's try a final example. Example 3. And example 3 says evaluate. Okay, so basically we're learning how to evaluate algebraic expressions now. And the one difference you have is this. Basically you have evaluate 4x minus 2y plus 3xy minus x if x equals 2 and y equals 1. Okay, and what this simply is we need to simplify the expression there and then substitute values for x and y into the expression. Okay, so let's just go ahead and do that. So we have 4x minus 2y plus 3xy minus x, and we need to bring like terms together. So what like terms do we have here? We have 4x and minus x. Okay, any other like terms? No, none at all. So 4x minus x minus 2y plus 3xy, when we solve that out, we end up with 3x minus 2y plus 3xy. Okay, and then the next thing we want to do is we want to then substitute values x equals 2 and y equals 1 into that expression. So anywhere you see x, you put 2, and anywhere you see y, you put 1. Okay, so um, we have 3x, so 3 times 2 minus 2y, so 3 times 1, okay, because y is 1, plus 3xy. xy means x multiplied by y, i.e. 2 multiplied by 1, and that's what you have there, 3 multiplying 2 times 1. Okay, and then what you have in the end is 6 minus 2 plus 6, and you have a final answer 10. And that is how you evaluate algebraic expressions. Okay, and that would be pretty much it for this lesson. That will be the end of this lesson. Very short, very simple lesson. Basic algebra. Algebra is actually really interesting. From this point on, we'll learn a lot of interesting concepts. We'll learn about the law of difference of two squares at some point, I think. We'll learn linear equations, and it gets even more interesting when you start working with things like quadratic equations. So, yeah. Bye for now.